Hello everyone. Welcome back to Dr. Lou's VCE Chemistry channel. Today, let's learn together about the 2020 VCE Chemistry. We will focus on questions related to equilibrium and rate of reaction. My explanation may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. The original equation is divided by 3 to transform the new equation. So, the new Kc is the cube root of the original, and the new delta H is 1/3 of the original. Note, the magnitude refers to a numerical value and does not require units. A catalyst increases the proportion of successful collisions but does not affect the frequency of collisions. So, A is eliminated. An increase in temperature always increases the rate of both forward and backward reactions. So, B is correct. A catalyst reduces the activation energies of both forward and backward reactions by the same amount, not the same proportion. So, C is eliminated. If the forward reaction is endothermic, the activation energy of the forward reaction is larger than that backward. So, D is eliminated. At 1 minute, both concentrations of Cl2 and CO increase, and CoCl2 decreases. This suggests that the reaction is moving backward. The forward is exothermic. So, temperature increases, and B and C are eliminated. At 7 minutes, all concentrations decrease sharply. This suggests that the volume of the system increases. So, D is eliminated and A is correct. The forward is exothermic. NO2 is brown, and N2O4 is colorless. At T1, the rate of forward reaction increases. At T2, it attains the platform. Since the rate of reaction increases, the temperature is increased. So, C and D are eliminated. Since the forward is an exothermic reaction, increasing temperature pushes the reaction backward. NO2 is brown. So, the system will be darkened, and B is correct. Ethanoic acid has a lower heat of combustion, compared with methyl methanide. So, ethanoic acid contains lower chemical energy, and C and D are eliminated. Methyl methanide has a lower autoignition temperature than ethanoic acid. So, its activation energy is lower than ethanoic acid. B is eliminated, and A is correct. The same amount of ethanoic acid and methyl methanide are completely combusted in 2 separate closed vessels. They produce the same amount of carbon dioxide and water. So, the chemical energy of products and gases would be the same. So, C and D are eliminated. However, the heat of combustion of ethanoic acid is lower. So, the temperature of ethanoic acid is lower. The lower the temperature, the narrower the Boltzmann distribution. So, A is eliminated, and B is correct. The reaction in methanol production is exothermic. The catalyst is used to accelerate the rate of reaction. The catalyst decreases the activation energy but does not change the enthalpy of molecules in reaction. Higher temperatures lower the yield of methanol. The forward reaction is exothermic. According to Le Chatelier's principle, if the temperature increases, the system will move to lower the temperature by favoring endothermic backward reaction. The higher the pressure, the higher the yield of methanol. The particle of products is less than that of reactants. According to Le Chatelier's principle, at high pressure, the system moves to decrease pressure by favoring the reaction that produces fewer particles in a given volume, thus increasing the yield of methanol. It is easy to write the expression of equilibrium. Note, CO is a reactant, not CO2. Initially, there is carbon monoxide and hydrogen, but no methanol. At equilibrium, 0.122 moles methanol is produced. The amount of methanol is key to calculating the concentration change. Finally, we calculate the final mole of reactants and products. Don't forget that moles should be converted into molar concentration because units in the equilibrium equation are molar concentrations. To investigate the effect of temperature on the rate of production of carbon dioxide gas, the reaction occurs at different temperatures, and the volume of carbon dioxide is measured. As the temperature decreases, the time for completion increases. Refer to the safety data sheets for each of the chemicals or a prepared approved risk assessment document. Follow all suggested storage, handling, and personal protective equipment guidelines given in the material safety data sheets. The aim is the effect of temperature on the rate of production of carbon dioxide gas. So, the independent variable is the temperature of the HCl solution, and the dependent variable is the rate of production of CO2. As the temperature increases, the rate of reaction increases. Increased temperature increases the speed of particles. The increase in speed increases the frequency of collisions between reactants, thereby increasing the rate of the reaction. Increasing temperature also increases the kinetic energy of particles. This increase in kinetic energy induces that a greater proportion of collisions overcome the activation energy barrier so that a greater proportion of collisions are successful and the rate of reaction increases. Yes. If the data is presented using a best fit, and if the outlier is ignored, the overall trend is declining as the temperature declines. The temperature is the independent variable, so it should be on the horizontal axis. The rate of reaction, the dependent variable, should be on the vertical axis. Use a more accurate way of measuring the volume, for example gas syringe. The balloons may have different shapes, which means that the volume of each balloon when it rises 10 centimeters over the top of the conical flask may vary. Use uniformly powdered Cocoa 3 to minimize surface variations. 6 multiple-choice questions worth 6 marks, and 2 short answer questions worth 22 marks in this section on equilibrium and rate of reaction. The overall score for this section is 28 marks. With a total possible score of 120 points, the percentage for this section was 23.3% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.